Hello, hi, good afternoon. My name is TeckChun from NCS. Today I'll talk about measuring green software, right? So, what is green software, right? It's an unconventional topic, but I think it's up and coming, right? Green software simply means software that emits the least carbon, right, in your code and in your software operations. And it also means the practices around your SDLC, right, how you build to operate your software. So that encompasses the whole definition on green software, right? And there are three principles if you want to be really a green software certified, right? So first is energy efficiency, right? There are two dimensions to this. One is PUE, or power usage effectiveness. We should always aim for running our workloads in data centers or providers with low PUE, right? PUE is a ratio where you measures how much of your power is used to power the service versus how much of the same power is used to cool the service, right? So obviously an ideal PUE is 1.0, which is not practical because every server needs cooling, right? So when you run your workloads, you should look for providers with very low PUE. 1.x PUE is actually quite good, right? Second dimension is about energy proportionality, right? It's again another ratio, right? It measures the power consumed by the servers versus what is utilized by the servers, right? So what this means is that don't leave your servers power on but not doing anything, right? That's plain inefficient. And also, it takes time to warm up electrical appliances, electronics, in order to convert electricity into useful computing operations. So second thing to take note about energy efficiency is not leave it running but not doing any work, right? The second principle is hardware efficiency, right? So every hardware that you buy or you deploy already incurs carbon, right? It's called embodied carbon, right? So it's a carbon that you incur when you manufacture the hardware and when you retire the hardware. So that cost is incurred. The climate or environment is already hurt in a way. So if you extend your server lifespan, you amortize your carbon footprint or embodied carbon over more years. So you buy server later. Right? That means the environment is now safer, right? And related to this is actually increasing your hardware utilization, right? So it's better to pack and maximize your compute estate space per server, right? Rather than have multiple servers running at lower utilization, right? So that's the second principle. So I think these are not new things. We already are doing some of this today. The third thing is new. It's quite advanced, and we don't see anyone doing this at scale yet. There are three dimensions. One is spatial shifting, right? If you can run your workload outside your country, right, you can look for regions or AZs that are green, right? So not all data centers are the same green. Some are fully powered by renewable, some are semi. So if you can run your workloads outside the country, look for something that you can shift to different geographical locations. Second dimension is temporal shifting, right? It means shifting the time where you run your highly computational workloads. If you know your grid is green at this time, run your high-intensive workload during this time. If it's dirty, then don't run, right? So that's a concept of temporal shifting, time shifting, right? The third dimension is demand shaping, right? It means you don't shift the time when you run a job. It still runs at the prescribed time, but depending on how green the grid is, you increase the computational power to do more. And if it's dirty, you do less, right? So an example is, for example, if you're a streaming company, you can stream SD, right? If the grid is dirty, right? And you stream HD, right? If the grid is cleaner, right? So those kind of thing is called demand shaping. So in a nutshell, green software is not just about code. As you notice, we haven't talked about anything about code efficiency. It is important, but it's not the only thing. So I just want to emphasize green software is not just about code. It's also about the operating environment and the practices surrounding this, right? Then why is green software important, right? So this is Mark Edrison. He's a renowned VC now. He's also the inventor of Netscape Navigator, for those who are a bit dinosaur like me. So he said 10 plus years ago that software is eating the world. So today, software has eaten the world, right? And AI is eating the world, right? And what this means is that you're going to have more and more software, more and more energy-intensive data centers being built. So if we don't do anything, we project by 2040, which is less than 20 years now, our industry will contribute to 14% of the global carbon emission. It's more than flying, which means that if you see an office type code deployed to cloud, you can actually burn a bigger hole. So that's quite jarring. So we need to do something. But then how do we start? Where do we start? By learning about green software and its practices, right? So the first port of call is to visit the Green Software Foundation website. So you can type greensoftware.foundation. This is where you find all the resources. This is where you find all the resources regarding green software, right? And I suppose I have a video, but I think I will not share the video because I'm running out of time. Leave it to you to explore the website. But I do want to point to you about the software carbon intensity, which I will elaborate in the next slide. Right, if you cannot remember what I said today at the end, you should remember this three-letter acronym, SCI, right? So software carbon intensity, right? So what is it? In short, it's a metric that measures how green your software is over time. Right? So that is the metric, right? So a very simple formula, right? Let me just break it down a bit so you understand, right? So the SCI comprises of a few components. First is E times I. E times I is our operational carbon, meaning the carbon that you incur when you run your resources, right? And how do we measure that? So there are two parts to this. One is E, basically your energy consumed by your CPU, storage, memory, your network. That is for that resource. And you multiply this by the emission factor of the power grid that is powering your data center. Emission factor is publicly available info. You can search for it, right? And you do that multiplication, you get the operational carbon of your resource. And you have to add in your embodied carbon, which cannot be changed because you already bought the hardware. This total will become your total carbon footprint for your resource. And the last thing you need to do to calculate SCI is to know what is your R, right? What does R means here? R is a functional unit, right? So it can be anything that you define. If your application is scaling by number of users, then your R is number of users. If your application scales by number of requests, then the R is number of requests. If it scales by number of concurrent sessions, then your R is number of concurrent sessions, right? So it's quite easy, right? You can define this for your own application. So what do we do with this formula? We take this formula, calculate the SCI for each of the resource, for your VMs, for your storage accounts, for your containers, and they add them all up. That will become your SCI for your entire application, right? So the million-dollar question is, higher SCI good or lower SCI better? So the answer is you should always strive for a lower SCI, right? So we should decrease the numerator, increase the denominator. What does this mean? It means we should reduce the operational carbon while increasing the utilization per resource so that the SCI is lower. So collectively, if you tune different parts of the application, the entire SCI for application will be lower. So why SCI, right? I keep talking about this acronym because it is a standard from the Green Software Foundation. It is a common metric now that will talk to your vendors, to your peers, your partners about how green your software is over time. And like I say, because of the R, you can calculate SCI for any software, including SAP system, right? If you know the carbon incurred by the instances, and you know how you scale a SAP by whatever the R functional unit is, right? And it's now an ISO standard from this year. So by embracing SCI, we are also compliant with ISO. I'm going to go a bit faster on this, right? I just want to anchor on the bigger picture on why SCI is also key in helping us with the net zero strategy, right? So today, if you want to reduce carbon, there are two ways to do this. One is carbon neutral, and one is net zero. Some people use them interchangeably, but they are not the same, right? So you can be carbon neutral by buying offsets, say carbon credits. You can plant a tree, for example. You can create a carbon sink with the society, a community project. But if you do all this, but you don't green your own operations, you can call yourself carbon neutral. That means your operation is still dirty, even if you do all this, right? But net zero is different, right? It actually forces you to look at your own supply chain and your scope 3 to reduce your carbon emission, right? And therefore, net zero is the de facto strategy that most tech providers are going after today. So you can see all the pledge about 2030 net zero strategy, right? And it's science-based target. So for SCI, it is it complements this quite well because it supports a net zero strategy. If you look at the formula, you need to reduce your carbon emission, right? And you increase your utilization. So you actively reduce your emission. That's a net zero strategy, right? Last 3 slides. So this is what we do in NCS. So we created a platform, a team called the Green Code Foundry. And now we are able to measure SCI for all our projects that's running on our Azure cloud, right? And the key to this is this green fella here, right? This is the impact framework from the Green Software Foundation. It is a framework and an engine written in Node.js that will allow you to calculate SCI for any resource, right? So there are various plugins to this framework that we use. For example, there's a plugin we talk to the Azure to get the utilization for the VM. There's a plugin where we calculate the energy for the CPU storage memory. There's a plugin we use for calculating the operational carbon, the embodied carbon for the VM instance type. And finally, it derives the SCI for the VM, right, for the resource type. And this is quite key. And we orchestrate the whole thing through GitLab. And the input is a list of CSV for the resource we want to measure. The impact framework actually outputs CSV as well. So we have to convert it into Postgres for display, right? So we'll show you in the next slide what it looks like. This is not the most current, but it's representative. So we measure our SCI for our internal developers platform called CodeSpark, right? And we measure this daily. So we have SCI daily. If you can see this chart, these are daily time series. So we measure the carbon for the day. This is the green bar, the request for the day, and the SCI for the day. So we plot this over a long period of time, then we can reason about how green the particular resource is. And we do this for every of the VMs and the other resources that we run under the CodeSpark, right? So why is this important, right? Because you cannot improve what you cannot measure, right? So this is the first step, and a very important first step. Right. This is the last slide. So I just want to say a few things about challenges facing green software. It is a nascent domain, therefore there is still a lot of complexity in terms of trying to greenify legacy system, for example, right? And if you just want to be green software through code, brute force it, I think it's quite challenging, right? You need to look at the operations, right? And resource constraint, right? To do this well, we need to invest in a team, like what we did, right? You need to pull in the right expertise, the cloud people, the software engineers, and you need to evangelize, educate people, and this requires resource. So you need to form a team. And related to this is actually culture of the organization. Are they supporting? Do they know enough about green software? Is this part of the ESG strategy, right? So it's important that the culture part needs to keep in place. But today, I think green software engineering is not top of the mind. I think we see this as a hurdle. And last but not least is how we measure and the tooling, right? We show what SCI can do, and we can do that. But for example, if you want to measure multiple apps in one VM, today the tooling does not support that. We have to write our own plugins. So there's still a bit of work to be done, right? And especially at the code level. If you are developers, you're optimizing your code for greenness, right? You want to know before, after. Today, there's no tooling that allows you to do this thing quickly. The feedback loop is just not there, right? So I think in closing, I just want to say, the list of challenges here are actually opportunities in disguise, if you ask me. Because this is a nascent domain, and I really encourage all of you, our fellow craftsmen and craftswomen, to take your skill sets, apply this to green software, evangelize this in your own company. Go back, tell your boss, tomorrow I want to measure SCI for my software. So start with that. But the first thing you should do is to go to the website, greensoftware.foundation, and then immerse yourself with the resources, their GitHub repository, try out their tools. You will be compelled to take action, I'm sure. And with that, yeah, thank you very much.